In this video for section 10.2, we're going to look at situations where we are comparing two means. And this can happen if we have a situation where we're deciding between two alternatives. So if we need to decide between two products, evaluate proposals from competing agencies, or decide between two applicants for a position. And so we are extending our ideas from Chapter 9 about hypothesis tests to making comparisons between two populations. So in this section, we are going to consider situations where the samples from the two populations are independent. So we have two separate groups that we are taking samples from. Later, we're going to consider situations where they're not independent. So the key idea here again is that they are two separate samples. And the occurrence of a value in one sample has no influence on the occurrence of a value in the other sample. So we're going to be doing this process assuming that our standard deviations here are unknown and that we have independent samples. So just like before, we're going to start by writing our null and alternative hypothesis. Null hypothesis always contains the equality and the alternative is the inequality. That hasn't changed. What we're going to do is we're going to have our mu1 and mu2 on the same side of the equals or inequality symbol, and we'll see how we get that in a minute. So we have our two samples. We need to keep track of which one is which. That's kind of the tricky part about these problems. So we're going to have mu1 for one of our samples and mu2 for the other sample. And then another step that we have to do that we didn't have to do before is identify whether we can assume that the variances are equal or not. And remember maybe from Stats 1 that variance is the standard deviation squared. So to consider whether the variances are equal, we're really considering whether the standard deviations are pretty close to being the same or if they're pretty far apart. Sometimes the MyLab problems will tell you whether or not to assume equal variances. If we are assuming equal variances, there's a box to check in Minitab, and you will get different numbers depending on whether that box is checked. So again, we're using Minitab to calculate a p-value, and then the menu that we're using is the two-sample t menu. And we're going to get a p-value just like before, and just like before, we're comparing that p-value to the alpha that we are given to determine whether to reject or fail to reject the null hypothesis. And then we draw a conclusion based on that. So we're going to go through an example here. This is example 10.5. And we are conducting a test to determine whether name brand ink cartridges generate more color pages on average than competing generic ink cartridges. And so the key thing here is that we want to know whether name brand cartridges are more pages on average than generic. And so that gives us a sense of direction, and that gives us a direction for our inequality symbol. So we have a simple random sample of 10 users for the name brand cartridge, and they found a mean of 322.5, a standard deviation of 48.3. For the generic cartridge, they tested 8 cartridges, found a mean of 298.3, and a standard deviation of 53.3. And we have our alpha value here. So in our samples, our sample mean for generic is less than our sample mean for the name brand. However, just because the mean is less, that doesn't necessarily mean it's statistically significantly less. And so that's why we do our hypothesis test. So we're going to start here with our claim, which is that name brand is more pages than generic. And we're going to set our name brand to be mu1 and our generic to be mu2. And then we want to keep that in mind as we go through this, which one is which. So now let's write our hypotheses. So just like before, I'm going to start with my alternative. And so my alternative hypothesis is that mu1 is greater than mu2. Now, what I said was I want to have it so that the mu1 and mu2 are on the same side of this symbol. So the way that I do that is I subtract mu2 from both sides. So just a little bit of algebra here. Move that over. So I get mu1 minus mu2 greater than 0. So that is my alternative hypothesis. My null hypothesis, again, is the opposite of that. So it's mu1 minus mu2 is less than or equal to 0. So keep the mu1 and mu2 part the same, keep the 0 the same, just change the inequality to the opposite and then put the line underneath. Or if this is an not equal to symbol, null hypothesis would be equal to. So those are my hypotheses. Now I'm going to go to Minitab and do my test. So bring up Minitab here. I'm going to go to Stat, Basic Statistics, and go to toSampleT. Now I'm going to switch this to summarize data, since what I have in this problem is I have the summarized data. I have sample sizes, I have means, and I have standard deviations. If I have the raw data, then I would choose each sample is in its own column, and you'll be doing that later on, but for this specific problem, I have summarized data. And so I'm going to enter for sample 1 and sample 2 my sample size, sample mean, and standard deviation. So let's go back here. So my sample 1 is my name brand. That's what I decided down here. So sample 1 is the name brand, so I have 10 for my sample size. My sample mean for the name brand was 322.5. And the standard deviation was 48.3. And for the generic, my sample size was 8. Sample mean was 298.3. And standard deviation of 53.3. So once I have those entered, then I click on Options. Confidence level, again, I can leave that alone. And here it's showing me I always want to have this sample 1 minus sample 2. So whatever is first here is going to be the sample 1, and whatever is second is going to be the sample 2. That's the direction that it's going. So confidence level I can leave. Hypothesized difference is the right side here of my hypothesis, which in this case is 0. So if my hypothesis is just that one is more than the other, then that hypothesized difference is 0. For some situations, it might be something like if I wanted to test that a name brand cartridge could print 20 more pages than a generic cartridge, then my hypothesized difference would be 20, because I would be saying that the difference between them is more than 20 pages. But if it's just more than, just more pages, then I leave that as 0. And then my alternative hypothesis, again, I want that to match up. Difference is greater than the hypothesized difference in this situation, so that's what I'm going to select. Then I need to decide whether I'm checking the Assume Equal Variances box. So looking at my standard deviations, they are 48.3 and 53.3. I'm going to say that those are pretty close together, and so I can assume equal variances. Now again, in MyLab, a lot of times the problem will tell you, but there's usually a lot of text, and so you have to make sure that you're reading things carefully and picking out all of the information that you need. So make sure you pay attention to that. Then I can click OK and click OK again, and it's going to ask me about saving, and here are my results. So scroll down toward the bottom here. And then it's going to give me my t-value of 1.01 and then my p-value of 0.164. So t-value, again, that's something that you may need to enter into MyLab. P-value, you will also need to enter into MyLab, but this is what I'm using to make my conclusion. So my p-value of 0.164, I'm going to write that down over here. And then what I'm doing is I'm comparing that again to alpha. My alpha is 0.05. Is p less than alpha? No, p is not less than alpha. So p is not less than 0.05. So that means I fail to reject. the null hypothesis. And in terms of my situation, what that means is that I do not have evidence that the name brand cartridge prints more pages than the generic. So it's not sufficient evidence. That name brand prints more pages than generic.